The differentiation of a quotient of two functions. Quotients imply divide. So that's what quotient means to divide. So if you have one function divided by another function, so let's say we have y equals u as a function divided by another function v. U is first in alphabet, so that's why we use u again and v. U on top and then v. Now what we're going to do is to derive the formula for differentiation for quotient rule. So this formula is quotient rule. Quotient rule. So that's what we're trying to derive here. Now, with quotient rule, we have a function of f of x and f of x plus h, or sometimes it can be written as f of x plus delta h. Same thing. In a curve, you pick a point and then you pick the second point. Because you need to find the gradient, right? So we're trying to find the gradient. So point number 1 and point number 2. For point number 1, y, it has its y value, x value, u value, and v value. For point number 2, it has y plus delta y value, x plus delta x value, u plus delta u value, and v plus delta v value. Because we need to find the delta y, and then we divide it by delta x. Y plus delta y. We know what y is. So y plus delta y will be u plus delta u over v plus delta v. But I need to find delta y, so I need to take y to the other side. It becomes minus. So delta y equals u plus delta u over v plus delta v minus y. But y is u over v. So delta y equals u plus delta v over delta u over v plus delta v minus u over v. So now I've got fractions to work with. The common denominator will be v times v plus delta v. So delta y equals u plus delta u times v minus u times v plus delta v over v open bracket v plus delta v. I multiply these two together. That's what you see at the bottom. Well, before I do that, actually, I make them equivalent fraction. This one already has v plus delta v, so I just multiply by v. If I multiply this by v, I have to times the top by v. So that's what I've done, times it by v. This one already has v. It doesn't have v plus delta v. So I times the top by v plus delta v, and I times the bottom by v plus delta v. So that's why you see v plus delta v here. That's v. And so because now they have the same common denominator, which is v times v plus delta v, so now I can do expansion with this. So the expansion I'm going to do now is uv plus v delta u minus uv, that's u times that, minus u times delta v, u delta v. So this is v times u, that's uv, plus v times delta u, so that's u. Now I'm dividing that by v squared plus v delta v. Well, we need to first of all cancel out uv plus uv minus uv, we cancel out. So now we have left v delta u, that's u, minus u delta v over v squared plus v delta v. So that's the y. Now I need to divide both sides by delta x. If I divide this by delta x, I have to divide those by delta x. So I get delta y over delta x equals v delta u over delta x minus u delta v over delta x, that's u, divided by v squared plus v delta v. So now we need to do the limit situation here. In the limit, as delta x tend to 0, then we have delta u will tend to 0. We also will have delta v tend to 0. We would have delta u over delta x tend to the u over the x, delta v over delta x tend to d v over the x, delta y over delta x, that will tend to dy over the x. So we can now write this properly in the limit. We can now say dy over the x equals v du over the x minus u dv over dx divided by v squared plus, well, we only have the v on its own, but that's 0, so plus 0. Finally, the derivative, if you have y equals u over v, the y dx will be equal to v du dx minus u dv dx over v squared. So that's the derivation. That's the formula we would use when we're solving quotients of two functions. Quotient means divide, and that's divide. You're dividing one function with another function. So that's the derivation there.